So good morning everyone. So in previous class we learned about digital image processing and what is image and everything. Okay. Today we will discuss about what are the steps involved in digital image processing. So previously we learned we have different types of levels. Low level processing techniques, mid level and high level. So with respect to these three levels, what are the steps involved in image processing? Involved in image processing. So we have so many processing techniques. Out of many standard techniques we will learn. Okay. So this one is fundamental steps involved in digital image processing. So this is the block diagram of fundamental steps. So in that, first we want problem domain. What is problem domain? We have some images. So we have to perform processing. We have to process those images. So to process the image, we want some requirements. We want some requirements and we have idea about which technique we have to choose. Which technique we have to choose. Okay, that is the problem domain and knowledge base. Based on the knowledge base and problem domain, out of these steps, we will select any one and apply on images. Okay, in this, let us see what are the basic steps. The first step involved in image processing is image acquisition. Okay, what is acquisition? So in name itself, acquise means acquire. Okay, to perform basic image processing, we require some images. How we get images? By capturing the images, by capturing the real world. Okay, if you doesn't capture, we don't get images. So capture the real world images means acquiring, means getting images. How we get images? Using image sensors. How we get images? Using image sensors. Okay. What is the purpose of sensor? Converts one form of energy into another form of energy. What is the image sensor can do? It converts light intensity into electronic signals. Okay, electronic signals. This is the first step involved in image acquisition. So in unit 1, we will learn in detail about image acquisition, means different types of sensor, how it works. Okay, completely. And second step involved is image filtering and enhancement. So filtering means we performing some improvements to the filter, improvements to the images. Okay. Next, enhance means improving the quality. Enhance means improving the quality. How we perform these two techniques? By modifying the pixels. Modifying the pixels of the image. Pixels of the image. Okay. By modifying the pixels of the image, we improve the quality of the image. We improve the quality of the image. So the output of this one, the output of this step is more suitable than original one. Original one. Example applications, your Snapchat filters, Insta filters, hmm, everything. Okay, your camera filters. All are image enhancement techniques only. Okay. So what is the use of it? For human vision purpose. Okay. For human vision purpose. So here entire second unit. Your second unit, we will learn about image enhancement techniques. What are the techniques involved here? Okay. Mostly the modification of pixels can be done in spatial domain, means directly on image. Second one is frequency domain. Frequency domain means first we have to transform image into frequency domain. It can be done using image transforms. It can be done using image transforms. You will learn image transforms in unit 1 itself. Okay. So in second unit, completely second unit is about enhancement. It can be done in spatial domain and frequency domain. Okay. So enhancement means simply improving the quality of the image. How we can done it is by manipulating the pixels in the image. Okay, by manipulating pixels in images. Okay, next image restoration. Okay, image restoration. In name itself, we have the definition. Restore means we reconstructing the original image. Reconstructing the original image. Okay, which are affected from degradation and noise. So what is the difference between degradation and noise? Simple. Noise means whenever the image is transmitted from one place to another place, due to the external factors, image may be affected. May be affected. Okay. That unwanted signal is known as noise. Okay. Then what is degradation? While capturing the images, while capturing the images, due to the adjustment of lenses or some other purpose, okay, or due to the overheat, the images may get affected, may get affected. Okay, this type of unwanted signals is known as degraded images. Degraded images. Okay, so there is a lot of difference between degradation and noise. So in third unit, unit third, we learn about how to remove this degradation as well as noise. Okay, entire third unit. That is image restoration, reconstructing the original signal, which affected from degradation as well as noise. Noise means the signal affected from external factors while transmission. Degradation means unwanted signals occur during capturing of image. Capturing of images. While capturing, unwanted noise will be added. That is called degradation. Okay. Next technique is color image processing. So nowadays color is the most powerful descriptor of an image, right? So during color variation, we can identify objects immediately, right? For any object detection or identification through color, we can detect more perfectly. Okay. So for human vision, color is the powerful descriptor of any information. Okay. Any information. So this is not in our syllabus. So the basic color systems we have RGB. Next, we have NTSC. So many color systems are there. The basic color system is RGB. Okay. So what are the steps involved in color image processing? Generally, in olden days, we have gray images or black and white images. Okay. I will say in later class about what is black and white image, what is grayscale image in detail. So before that, color images. Nowadays, everywhere we have colors. Okay, we have colors. How we process these things? So we have whatever the image enhancement techniques are available in color image processing also. So these color image processing techniques are classified into two types: full color image processing. Next one is pseudo color image processing. Pseudo color image processing. So what is those? Full color image processing means the basic color system is RGB. Means we have three colors. Okay, RGB. So we modify these colors to improve the quality of the image. To improve the quality of the image. Okay, means we perform the techniques, whatever the techniques we have, compression or acquisition, restoration, filters, anything we perform directly on these basic colors. Okay, so by modifying these colors, we enhance or restore anything. Okay, that is full color image processing. Then what is pseudo color image processing? Pseudo color image processing means we first convert color images into either gray images or black and white images. Okay. Then we perform any processing techniques. Then we perform any processing techniques like filtering, enhancement, restoration, compression, whatever the techniques we have. Then we perform. That is pseudo color. Full color means directly we apply on colors. Okay. Next one is wavelets and multi-resolution processing. So what is wavelet? So wavelets are nothing but a sinusoid signal which has some particular range. These sinusoid signals, it needs sinusoids. We call as sinusoids. Okay, wavelets are small frequency signals. Okay, small frequency. The range is fixed, some small region. So these are used to represent the degree of resolution. Degree of resolution. Then what is resolution? Resolution is nothing but the size of the image. Okay, size of the image, dimensions of the image. Simply resolution means size of the image. Nowadays we called you applied gate application, right? In that the passport size photo is 320 by 280. Signature is 80 into 280, like that. They give some particular sizes. If you watch YouTube, we have select some pixel range 360p, 480p, 720p, 1080p, 2K, 4K. Okay, these are the resolutions of the image. Okay, then what is multi-resolution? If you watch the YouTube video, for same video we have different resolutions. Okay, we have different resolutions. So while playing the video, we can convert from one resolution to another resolution. If you change from one resolution to another resolution, the quality of the image is improved, right? So for the single frame, we have different resolutions. Okay, for single frame, we have different resolutions. So these different multi-resolutions we called as multi-resolution or image pyramids. We called it as image pyramids. Okay. So how this resolution are varied? How we get multi-resolution? Based on the wavelets. Because wavelet is some waves or simply a sine signal with a small duration of frequency. Okay, with a small duration of frequency. These wavelets will generate the resolutions. Okay, multi-resolution. Next technique is compression. This is your fifth unit, entire 15. So what is compression? Compression means reducing the size of the images. Okay, reducing the size of the images is called compression. So what is the use of compression? For transmission purpose, we use compression technique. Okay. Next one is morphological processing, your fourth unit. This is your unit 4. So here, observe here, they give an arrow mark here. From here to here, outputs of this process generally are images. Means up to from here to here, these are low level processing techniques. I said already, low level processing means input is image and output also image. Okay, means entire image is available in output also. So from here to here, the outputs are also images. Means these all processing techniques are low level processing techniques. Okay, and morphological processing. What is morphological processing? Simple. Probing the images means probing the images means probing means we separating the sum of the images, sum of the region of the images. Morphing means what? We modifying the images by removing some part of the images. Okay, so we removing background and we add some other backgrounds to our images, right? These all include in morphological processing. So how we create these, how we probe the images? Using some templates. Using some templates. The templates are called logical operations. Logical operations. Using these logical operations, we probe the images, means we crop the images, means we separate background from the foreground, like this. Okay, this is morphological processing. Here we have only basically two techniques, erosion and dilation. Okay. We will learn in detail in fourth unit. So sometimes the morphological processing outputs are entire images, sometimes some part of the images, some part of images. Okay, so some part of images are called attributes. Okay, means morphological processing belongs to low level processing as well as mid level processing. Okay, mid level processing. Next one is segmentation. Segmentation means partitioning of images. Partition of images means dividing the images into parts. Okay, means we splitting the images sometimes, or we combine two images sometimes. Okay, all these are related to segmentation. Next one is representation and description. So what is this representation and description? So it is representation means it is a raw data. Okay, it is a raw data obtained from the segmentation. So after segmentation, we may be split images into two parts. Okay, from these two parts, we have to represent the region. Means we have to represent some region. Region means our information available space. Okay, available space. We have to highlight something. Okay, we want borders, so we highlight the borders. We want boundaries of the image, or sometimes we have to region of interest. We want some region, we have to highlight something. Okay, those are all called representation for images. Then description means description is a feature selection. Okay, features like where we can call it as background, or this is a boundary, or this is edge. These are edges, these are boundaries, and this is background. This part is background, and this one is foreground. So we giving some description to the images. Okay, and last step is object recognition. Okay, object recognition. It is the important step in nowadays AI. Means after description of the process, we assigning a labels to the objects. Okay, means sometimes this is the face, this is fruit. Okay, for humans using the knowledge, we can say it is some object, it is fruits, but machines can say that no, we have to train them. We have to train them. So entire artificial intelligence is based on object recognition. The application of AI is the basic techniques used in AI and machine learning and deep learning is object recognition. Okay, means identifying the objects. Okay, this called object recognition. Next, so we know about till now fundamental step, means how we process the images. Then what are the components required for image processing? What are the components required for image processing? Means to perform image processing, we require some hardware or some software, right? So what are the components required? So these are the components required for image processing. First one is image sensors, means your cameras. Okay. Next, after images, we want some image processing unit, computers, image processing software. Okay. Next, to view the images, we require image displays. Okay. To store the images, we require storage devices. Okay. To transmit the images from one place to another place, you require network. And if you want to printing copies, hard copies, we required here hard copy means printers. Okay. Mass storages becomes hard disks, CDs, pen drives. Okay, everything will come. Image displays means LCD screens. Okay, projectors, all belongs to imaging displays. Okay, these are the components required to perform image processing. So basic one is image sensor, means camera. Without this sensor, you can't capture images. Without images, you can't perform any processing. Okay, these are the components required for image processing. Next is some applications. So application in medical field, we use image processing, right? So for pattern recognition or to identify the tumors, etc. In medical field, image processing is basic thing. Okay. Next, forensic, like thumb impression for iris. Okay, your Aadhaar card authentication through biometrics. Okay, fingerprint identification, iris identification, face. Okay, everything is based on image processing techniques only. So forensic. Next application is remote sensing. In remote sensing also we use image processing. Remote sensing means nothing but we capturing the environmental conditions or underground whatever the nature. Okay, those pics from those pics we perform image enhancement techniques or any other technique, texture classification, etc. What is the texture? Texture means some background. Okay, Earth surface based on the images, whether it is a water field or it is a soil or it is a rock, everything based on the image processing techniques only. So remote sensing, in remote sensing field, we require image processing techniques. Next in communication, transfer of the images, okay, from one place to another place, video conferencing, next live video, etc. Everything is based on image processing techniques only. Next, automated missions. Means automated missions means to identify the night vision system. Nowadays traffic lights are automated, right? Next, automated missions means some industries, in industries to tracking the objects. Okay, we use image enhancement techniques. Next, astronomy purpose, photographies, and to identify the targets, navigation paths in military. Okay, everywhere we use image processing techniques. Image processing techniques. Artificial intelligence. Also, we use image processing techniques. Now let us see the another important one, human visual purpose. Because one of the important descriptor for image processing means how we can say image processing is performed well. If you perform image enhancement, we improve the quality. How can you say the quality is best? By viewing the images, right? By visualizing the images. So to visualize the images, what is the important element? That is human eye. Okay, that is human eye. This is the structure of the human eye. Based on this one, human eye, we can visualize anything, color or anything. Okay, so let us see the basic structure of the human eye and important elements in the human eye. Okay, let us see here in this is the cross section of human eye. It consists of cornea, iris, lenses, okay, retina, blind spot. What are those things? Let us see. So basically the image eye, the important membranes are cornea, cilia. Okay, next one is choroid and third one is retina. So three membranes are there. See, first one, second one, third one. So entire eye consists of three membranes. Okay, cornea, cilia. So topmost area is called cornea and downside area is cilia. Okay, these are the transparent layers and tissues which protect the eye, outer layer. Okay, it is called outer layer of the eye which protect the eye. Next one is choroid. Choroid is present below the cilia. Okay, choroid is present below the cilia. So it contains the blood vessels. Mainly choroid consists of blood vessels. Okay, and the choroid is divided into two parts. Okay, entire choroid is divided into two parts. That is ciliary body and iris. Okay, ciliary body and iris, and it consists of a ciliary body and ciliary muscles. The ciliary muscles will give the movement to the eye. Okay, and what is the use of this ciliary body and iris? Okay, the iris front part is consist of a black pigment. Okay, visible pigment which contains, see, this is the black pigment which protects the eye. So this is the basic lens, and outside the lens there is some pigment the iris consists. So the use of this iris is it doesn't allows any other light. Generally, the whatever the light we view that enters through lens, only this part. So the light doesn't enter through this part. Okay, if it enters from this part, it affects the blood vessels. So to avoid this one, the ciliary muscles consist of iris. The iris is coated with a black pigment. Okay, the iris is coated with a black pigment. Okay, to avoid the light entering from the other sides, other directions, except through focal length. Okay, in this direction only light have to enter into your eye. In this area, lens area. Other than this lens area, the light doesn't enter into the human eye. If it enters means the vessels, blood vessels get affected. Okay. Next one is important one is lens. It is the subpart of chloride. So what is the use of lens? It is made up of fiber attached to the ciliary body. Okay, it contains 60 to 70% of water. Okay, 62%, and it enters the, it accepts the light. Okay, it accepts the light. Next one is retina. Important layer is retina. So what is the use of retina? Okay. The innermost membrane of the eye is retina. So whatever the light focused on the lens, that get be reflected on retina only. Okay, the lenses, whatever the light focused on the lens is reflected on retina only. Okay, the retina consists of receptors. Okay, it receives the signals. The retina will receive the signals. So the receptors are two types, cones and rods. Okay, cones and rods. The cones are useful for bright vision. Bright vision means color vision. Okay, color vision. Rods are useful for dim light vision. Dim light vision or scotopic. Cone vision is called photopic. Okay, dim light vision, bright vision. Okay, where the rods and cones are located, mostly in this fovea region. Okay, fovea region, this is the fovea region. In this fovea region only the rods and cones are available. So whatever the light intensity is focused on the lens, it gets reflected on retina and mostly on fovea region. Fovea region. The fovea region consists of cones and rods. Okay. Cones are used for color vision. Rods are used for dim light vision. Okay. Then here there is one more thing is blind spot. What is blind spot? It is the region near to the fovea which doesn't consist of rods and cones. The area which doesn't consist of rods and cones. If it is very narrow means good. If it is very wide, then the person has blindness. Okay. If it is medium, if it is medium and based on the ratio of rods and cones, we can call it as color blindness. Okay, color blindness. If the person has only more rods and less cones means that is color blindness. It is called blind spot. Okay. These are the important membranes in human eye. Okay, human eye. Blind spot, rods and cones. Mainly based on the rods and cones only, human vision is possible. Okay. Next, how images are formed in the eye. Next, how images are formed in eye. Generally, in ordinary photograph camera, the lenses has fixed focus length. The focusing varied by varying the distance. Okay. Generally, if you capture the images through camera, the lens has a lens. The lens focal length is fixed, right? It doesn't varies. The focal length is doesn't varies. So to focus an image, we have to vary the distance between image and image plane. Means object and image plane, right? We just vary the distance between the image plane and object. But in human, the distance between lens and retina is fixed, right? The lens and retina distance is fixed. We observed previous. The lens and retina area is fixed. Okay. Then how to vary the focal length? See, the lens area will be varied. The lens focal length will be varied. Will be varied based on the ciliary muscle. The ciliary muscles will provide the movement to the lens. So the size of the lens will be varied, means focal length is varying. So due to the variation of the focal length, we can visualize the images. We can visualize the images. So let us see how the images are formed. So let us consider this is the one image. Okay, this image, how it is formed? It is formed in inverse form. Okay, it is formed in inverse form. Where it is formed? At the fovea region. At fovea region. Okay. So how the lens are varied? Listen. Lens get flattened. Lens get flattened means thinned. Lens get flattened or thinned to focus distance object. Distance objects. Okay, important one. Next, lens gets thickened to focus nearest objects. Okay. So based on that, the focal length of image is varied between 14 millimeter to 17 millimeter. Okay, 14 millimeters to 17 millimeters. Let us see a small problem here. How the images are formed? Images are formed inverse and which region? Fovea region. Okay, fovea region. So how the lenses are varied? For flattened images, lens get flattened to view distance objects. The lens get be thicked to view nearest objects. To view the nearest objects. Okay. Let us see a small problem. Let's consider the object of this tree. Height of this tree is 15 meters. Okay. And you are located here, means human eye is located here. The distance between object and human eye is 100 meters. Okay. 100 meters. And the focal length is 17 millimeters. Okay. Then what is the height of the image formed in the eye? Formed in the eye. What is the height of the image found in the eye? Let us see. This is 15 meters. This is 100 meters. Right? Now, this one 17 millimeters. This one we don't know, H. Okay. Using concurrency of triangles. Using concurrency of triangles. What we can say, if two triangles are concurrent, the ratios of their sides must be same, right? The ratios must be same because both are same, looks like same triangle. So then ratios must be same. So based on this property, let us calculate. 15 by 100 is equal to H by 17 millimeters. Meters cancel. H is equal to 15 into 17 millimeters by 100. Okay. Means 2.55 millimeters. Okay. So how the images are formed? Inverse form. Next important concept in human eye is brightness adaptation and discrimination. What are those two things? Brightness adaptation and description. Let us consider an example. Small example. If you enter in a theater, you went to a movie, after 15 minutes of show starts. After 15 minutes of show starts. Okay. Whenever you open the door and immediately close the door, will you find your seat? Will you find your seat immediately? No, right? You doesn't find your seat immediately. Okay. You can't visualize your seat. Okay. But after whenever you sit in your seat in same dark region, after sometimes you can visualize remaining persons, right? Whenever you enter immediately into dark region, can you visualize anything? No. Can you visualize anything? No. But after some time, you can visualize anything. Okay. Means what is the brightness adaptation? Brightness adaptation is nothing but when you enter into dark region from bright region. Okay. When you enter suddenly into dark region from bright region, it takes some time to avail brightness. Okay. Means to adapt the brightness, it takes some time. Okay. This process is called brightness adaptation. Okay. Then discrimination means ability of human visual system to adapt the brightness. Means there is some time, right? Some time to adapt the brightness. This time is referred as discrimination. So generally brightness is theoretical description, right? Or subjective description. How can we say brightness is good or bad? By observing through height. There is no any mathematical value, right? There is no mathematical value. We said the brightness is good, the brightness is bad, low brightness, high brightness. We just give some justification only for brightness. There is no mathematical representation. So to represent the brightness in mathematical representation, we define one parameter, that is Weber ratio. Weber ratio. It is a ratio of change in illumination to the illumination of the object. Okay. Change in illumination to the illumination of the object. This is the Weber ratio. Based on this Weber ratio, we can explain about brightness. Okay. We can explain about brightness. And next important concept in human eye is optical illusion. So what is illusion? It is the effect appeared in visual system where the images appear different compared to reality. Compared to reality. In reality, the image description is one thing, but human eye, it looks different. For human eye, it looks different. Okay, it looks different. See how it is. So optical illusions are classified into two types: matchband effect and simultaneous contrast. What is those? Matchband effect. Observe this image. Observe this image. Here the region is very dark. Here some more bright, some more bright, some more bright, some more bright, some more bright. Right? You are visualizing this one. But actually the intensity values are like this. Actually the intensities are like this. Only at this area only the intensity is varying. Okay. Here the intensity value is 0. Here the intensity value is 1, 2, 3, 4, 5. Okay. Here the intensity value is 1. So up to here the intensity is constant. Nothing. There is no anything. Okay. But until the change in intensity, the up to this region, the visual system is black, right? One color. But basically the color is changed here and here only. But in between these two, the color is same as this one. Same as this one. Now observe here. From here to here, the intensity is changed. But in between the region, we visualize the color of this intensity. We visualize the color of this intensity. Same thing. Here to here, we visualize the same intensity. So this effect is match band effect. Okay. Means here there is no black color in this region. But our eyes visualize this one as black color. In this area, there is no color. Only here and here is the color. In between this area, there is no color. But due to this intensity and this intensity variation, in between the region, we visualizing some color. We visualizing some color. Okay. This effect is called match band effect. Another one is simultaneous contrast. Simultaneous contrast is nothing but based on the background and foreground colors. Okay, the color vision is differed for human eye. Okay, okay, based on the region colors. Okay, our human eye perceives the different contrast. Okay, let us see this example. In this example, here see the center square box. The center square box is same color. For three images, the center square box color is same. Okay. Due to the background, here the background is very black, so that it appearing like white color. Okay, it appearing white color. Here, some more light. Here, it looks like a black. Okay, it looks like some gray color, but all intensities are same due to the background variation. Due to the color variation in background, the foreground color is varying for human eye only. For human vision only, the color is varying, but actually the color is same. This effect is called simultaneous contrast. Means based on the background region, the foreground image intensities are varied. See, they appeared progressively darker as background becomes lighter. But actually the all inner square has same intensity. Okay, this effect is called simultaneous contrast. So let us Google optical illusion images. Okay, optical illusion images. Let us see, so that you can get more examples in that. Let us see some more examples in optical illusion. Or you can Google it. In movies, they show a flashbacks like circles. That is illusion example. Okay, let us Google them. We get so many images. So here observe these images. These images observe. Here there is no rotation of this thing, but in your eyes it shows it is rotating. These images. Okay, it looks like a rotating. This is called optical illusion. Okay, see here some examples. These are all